Hey guys, welcome. Yeah, so we're in section 2, which is FRQs, part B, because no calculator section of the FRQs is called part B. And there are 4 questions in part B where you are not allowed calculators. And those are problems 3 through 6. And here we're doing problem 3, part A. There's more to the description of problem 3, but the rest of the description in problem 3 is summarized in this visual. We see that we're given f prime, and there are some important information about f prime based on the graph given here. Okay, cool. Now, when you get a question just like this, remember I've said before that the AP loves repeating similar ideas from year to year and similar questions from year to year. So if you get a similar question to this, to answer something like that, recall the evaluation theorem, which said that the integral from a to b of f prime of x dx is equal to f of b minus f of a. Remember, the evaluation theorem said that. Yeah? Okay, cool. So then, if you adopt this statement to our situation here, then you'll be able to find f of negative 6 and f of 5. And since the only thing we know about f is its value at x equals negative 2, either this limit or this limit will have to be negative 2, depending on whether we're answering this question or this question. Now remember, when we write limits of integration, we like going from a smaller number to a larger number. So when we write this statement so that it helps us find f of negative 6, we will go, we know that the integral from negative 6 to negative 2, so we had to involve negative 2, right? And negative 6, because that's what we're finding. And as we said, we want to go from the smaller number to the bigger number. I think this is the easiest way forward in answering this question. There are other analytical things you could do, but yeah, I think you should elect something like this anytime a question similar to this is given to you. Anyway, negative 6 to negative 2 of what? Of f prime of x dx. Now we know that this is equal to f of negative 2 minus f of negative 6. Then since we're looking for f of negative 6, we can use this equation and solve for f of negative 6. And if you do that carefully, you should find that what you need to write is that f of negative 6 is equal to f of negative 2 minus the integral from negative 6 to negative 2 of f prime of x dx. So to get from here to this statement, from this statement to this statement, all we had to do is first, from this equation, subtract f of negative 2 from both sides of this equation, and then divide by negative 1, and you'll be able to get of the resulting equation, that is. So after subtracting f of negative 2 from both sides of the equation I just circled, in the resulting equation, if you divide by negative 1 on both sides of the resulting equation, you'll be able to get this. Yeah? Okay, cool. And we know this, that's given, it's 7. And so all we have left to do to figure out f of negative 6 is write 7 minus, and then figure out the value of the integral from negative 6 to negative 2 of f prime of x dx, right? Okay, cool. Now, what does this mean? We know that that means that we're looking at the area under the curve f prime from x equals negative 6 to x equals negative 2. So what we're talking about is this area right here. Let me first bound it on the left. But yeah, like we're talking about this area from x equals negative 6 to x equals negative 2. That's the area of this triangle, this right triangle right here. Yeah? Okay, cool. But the area of that right triangle is easy to compute. Its bases like that, right? So that's 1, 2, 3, 4. And its height is 2. So that's going to be like 1/2 times 2 times 4. And therefore 4. So what we've got is f of negative 6 is 7 minus 4, or 3. Yeah? Okay, cool. So we've answered that. F of negative 6 is 3. And now we need to move on to f of 5, which is a tad bit easier in some ways. Okay, well, one way is because you've just benefited from the discussion of how to find f of negative 6. And so this, as I just said, is 3. So for f of 5, we do a similar thing, but this time the lower limit is negative 2 because negative 2 is smaller than 5, right? So we go like the integral from negative 2 to 5 of f prime of x dx, right? We know that this is equal to f of 5 minus f of negative 2. So this time, all we have to do to find f of 5 is from this equation, add on both sides f of negative 2. So like f of 5, we can easily see is going to be f of negative 2, and then plus the integral from negative 2 to 5 of f prime of x dx, right? Okay, cool. Now this again we know, and we know it is 7. So we write that f of 5 is equal to 7, and then plus what? Plus the area bounded by the curve f prime and the x-axis from negative 2 to 5. This time, the area we're talking about is this blue area. We're going from negative 2 to 5. So this area of the semicircle plus the area of this triangle, right? Okay, cool. The semicircle is pi r squared over 2. So let's do that. So pi and then r squared. R is clearly 2. So r squared is going to be 4. So 4 pi would be the area of the full circle, but we want a semicircle. So pi r squared over 2 is going to say 2 pi. But because the area is below the x-axis, we know that its signed area is negative 2 pi, negative 2 pi, right? So we know that area below the x-axis has a negative sign to it, so it's negative 2 pi, right? Okay, all right, cool. So this part is negative 2 pi, and then the area of this triangle is like the base is 3 and the height is 2, so that's 1/2 times 2 times 3, so that's 3. But it's positive because it's above the x-axis. So we see that this here has value 3 minus 2 pi. So what we have to add onto 7, which is that, right, is 3 minus 2 pi, which means that we have 10 minus 2 pi as our answer to what f of 5 is. And this concludes part A. Keep watching. So f of 5, let me write, equals 10 minus 2 pi. All right, part B is coming up real soon. Hey guys, yeah, so part B here, and it's asking us where is f increasing. Remember, f increasing is synonymous with f prime being greater than 0, right? Wherever f is increasing, we know that f prime is greater than 0. So since we were given the graph of f prime, we just need to look and see where f prime is above the x-axis. That clearly happens from x equals negative 6 to x equals negative 2, and then again from x equals 2 to x equals 5. Now, so what we're saying is we can summarize the places where f prime is greater than 0 as being the following two intervals, which is negative 6 to negative 2 and from 2 to 5. Notice that when I report where f prime is greater than 0, I excluded x equals negative 2, x equals 2, and x equals 5, because at x equals negative 2, at x equals 2, and at x equals 5, f prime is actually equal to 0, right? However, when I answer this question, which is when I say where f is increasing, I have to include all 3 points here, negative 2, 2, and 5. And the reason is because you can't talk about like a function being increasing or decreasing or neither at a point. Like in order for you to talk about a function being increasing or decreasing, you need to have some interval, right? An interval of length greater than 0, right? And a point is not an interval. I can answer more questions about that if you have them, but my point is that like while f prime being greater than 0 is correctly answered there, your answer for where f is increasing needs to say f increasing f increasing on, and then it's -6 is, that was poor. -6 is less or equal to x is less or equal to -2, and 2 is less or equal to x is less or equal to 5. And what you expected differently is that this would be strictly less than, and likewise there and there, but not true. Yeah? Okay, cool. Keep watching. Part C coming up. So in part C here, we have to find the absolute minimum value of the function f. Yeah? Okay, cool. So how do we do this? Well, remember, absolute extrema, whether it's absolute minimum or absolute maximum, require that we consider values of the function f at the endpoints, and then where f prime is equal to 0, or where f prime is undefined. Okay. Yeah? Now, we know that there are no places where f prime is undefined, right? F prime is defined everywhere. So we can rule this out. So we could just concentrate on the endpoints and where f prime is equal to 0. So for the endpoints, we know we've got x equals -6 on the leftmost endpoint, and then on the left endpoint, and then x equals 5 as the right endpoint. And so these are the endpoints. So we need to now figure out where f prime is equal to 0. That happens at x equals -2 for the first time, right? From left to right anyway. So x equals -2. And then at x equals 2. And then again at x equals 5. But we already listed that as an endpoint. So that's good enough. Now, what we need to do, we don't need to list it twice, right? What we need to do now is figure out the value of the function f at these 4 points, and then whichever gives us the smallest value, that's the absolute minimum, right? Okay, cool. So now what I'm saying is we need to figure out f of -6, and then f of -2, and then f of 2, and then f of 5. But wait, f of -6 we computed in part A, and it was 10 minus 2 pi. And then f of 5 we also computed in part A, and it was 3. F of -2 is given from the start, and so that's 7. And so the only thing we have to find is f of 2. And we're going to find f of 2 the same way that we found f of -6 and f of 5 in part A. That is, we're going to write, since we're looking for f of 2, we're going to write that we have -2 to 2 of f prime of x dx is equal to f of 2 minus f of -2. But then that means f of 2 is equal to f of -2 plus the integral from -2 to 2 of f prime of x dx. I don't like that d, sorry y'all. Dx. Yeah? Okay, cool. Now this, as we've already said, is given, so that's 7. And then this here we calculated in part A, right? And it's the area of this semicircular portion of the graph, or semicircular area. And since it's below the x-axis, we said that its value is -2 pi as opposed to +2 pi, right? Okay, cool. So we see that we've got 7 minus 2 pi is the value of f at x equals 2. So this is the smallest because 2 pi is about 6.28, right? Since pi is 3.14, and 7 minus 6.28, or this quantity, is definitely between 0 and 1, and all the others are bigger than that, right? So yeah, 7 minus 2 pi, and therefore our absolute minimum value of f is 7 minus 2 pi, and it's attained at x equals 2. Now, before I move on to part D, I just want to quickly comment that while we've been writing this to help us figure out the values of f, it makes perfect sense. Think about it. The value of the function f at 2 should be the value you started off with at x equals -2 plus the change in value of f from -2 to 2, right? That's what this says, the change in the value of f from -2 to 2, right? That plus the value you started off with at x equals -2 should be your value at x equals 2. Yeah? Okay, just wanted to, yeah. Anyway, part D coming up, and yeah, let's wrap this up. Cool, keep watching. Part D here, and in this part we have to find f double prime of -5 and f double prime of 3. And so remember, f double prime in this question is talking about the slope of f prime, right? And in general too, f double prime is talking about the slope of f prime, right? Okay, cool. So f double prime of -5 means the slope of f prime at x equals -5. Well, lucky for us, f prime has a line segment in this part, right? From like x equals -6 to x equals -2. So the value of f double prime from x equals -6 to x equals -2 is constant because it's the slope of that line. And the slope of this line, if you like pick 2 points, like one here and one here that we know are definitively on the line, then you'll find that the slope of the line is -1/2, and that's just like algebra 1. So then that means f double prime of -5 is 1/2. Okay, whereas f double prime of 3 is undefined, and this is undefined because at x equals 3, the graph of f prime has a sharp turning point, also known as a cusp. So you'll want to say a little bit more, but yeah, basically you can say like the slope of f prime from the left, which is like the slope of this line, does not match the slope of f prime from the right, which is the slope of this line. So like at a sharp turning point like this, like, yeah, the function whose slope you're trying to find is like confused, because like the slope from the left is not the same as the slope from the right. Yeah, okay, cool. All right, keep watching. Take care.